The first thing is to be able to take an equation in here, this standard form, and find x-intercepts, y-intercepts, and sketch the graph. Now, we have methods for doing this by hand, and a lot of times that's just going to be the most efficient way to do it anyway. So kind of keep that in mind. If you keep that in mind as you're kind of going through, what you may find is that it's a more efficient method for solving it just by doing it by hand. But if you wanted to solve this by using your ti89, you can do a couple different things. One, you can solve for the x and y intercepts by using the or by evaluating the function from that you're given. But in order to evaluate it, or if you're going to use the graph of this, what you need to do first is you need to put it into slope-intercept form. So the very first thing I'm going to do for this is I'm going to solve this equation for y, which is putting it into the slope-intercept form. And that's an equals 8 there. So I'm going to solve for y. Notice I write my whole equation, comma y. This is going to give me my formula. And notice that when I write this formula, I'm not going to write it as one single fraction. I'm going to write it as individual terms. So this division of 2 happens to both. So it's 1/2 x minus 4 over 2, which is 2. Okay, so I'm just going to simplify what I have, but write it in this form. Because now this shows me what my y-intercept is, right? I know from this form that my y-intercept is 0, -2. And if I wanted to sketch this, what I can do is I can go into the graphing utility here. So I need to write this equation here and store it as y1. Okay? So if I go into my y editor and I write the equation up there that I write here, this 1/2 x minus 2. So that's the equation that I'm entering. If I put that into my y editor, I can then go into that graphing utility and see what the graph looks like. Notice I have my y-intercept at -2. My slope is up 1 over 2. So that would still be easiest to find just using the normal method. But the graph on the calculator is going to confirm this. So there's the graph of this. And if I want to find the y-intercept right here, again, you can find the y-intercept a couple different ways. You can set the plug in a 0 and use the solve feature to find x. But if I'm on this graph right here, I can also go to the math tab and choose my 0. The 0 tells me where it crosses the x-axis. And so I just need to set a lower and upper bound to find that 0. So I want to find the 0 that's between somewhere to the left of this intersection. So my crosshair is to the left already, so I'll set my lower bound here. Then I'm going to scroll across until I get, and the way I can find out that it's above the x-axis is when those y's turn positive. So notice my y's are still negative, 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 negative. Now they turn positive. So I could stop right here and it's going to give me that 0. I'm going to go ahead and just exaggerate it a little bit more. So now my crosshair is on the other side. I can find what's the 0 between that interval, and I see that it's the 0.40. And that indicates my x-intercept. Okay? So like I said, using the ti89 isn't necessarily the most efficient way to do these, but if you need to or you want to confirm it, you can do it that way. All right. So let's talk about finding slope. So depending on what the problem, like what the form of the problem is, you have some different methods for finding slope. If you have an equation in any form, probably the easiest way to find the slope is just going to be write it in slope-intercept form, and it's the coefficient of x. And so again, if I do the same thing I did on that last problem, I use the solve feature, type this whole equation in, and solve for y. So if I go back to my home screen, and I'm basically doing this same process. Solve, type the equation that's given, negative 9x minus 7y equals 6. And I'm going to solve it for y. This puts it into slope-intercept form. And that slope-intercept form. Notice this winds up being like a little bit more complicated. If you want to here, if you don't want to do this by hand, you can go ahead and move in front of your command here, and you can go back into your F2 algebra tab and select expand. Remember, you can jump to the back or the back of your line or the end of the line by hitting second and then your arrow key or cursor arrow key. If I do it this way, notice I put it in expand and now it separates those for me, so I don't have to do that. I get negative 9/7 x minus 6/7. And so if I'm looking to find the slope is just the coefficient of x. Negative 9/7 would be my answer. Okay, so that's finding the slope. All right. So this next slide, or the next thing I'm going to do, is I'm going to show you how to create functions. Okay, they're called user-defined functions. Okay, that you can name whatever you want to name it, as long as it doesn't interfere with something that's already like saved as that name on your calculator. Okay, and it allows you then to calculate anything that's formula-based. So if you're finding the slope between 2 points, what you'll do is you think about these points in terms of x1, y1 is how we did it when we worked with these by hand. The calculator already assigns x's and y's, so we don't want to use x's and y's for our user-defined functions. So I'm going to use h's and k's, h for the x, k for the y's. So I'm going to look at point h1, k1, and the point h2, k2. So if I look at this in just a generic sense, and I want to figure out what is the slope equation based on this input. So if I have an input of h1, k1, h2, k2. Okay, and so from that, my formula for the slope is going to be the difference of my y's over the difference of the corresponding x's. So that's the equation for slope if I'm using these 2 points. That's how we're going to do this with the calculator. Okay, the first thing we're going to do is we're going to use the command define. Okay, so I'm gonna write this out. These steps indicate everything, and I'll show you on the calculator too. But I'm just gonna find this little open space right here, and I'm gonna write all of these out so you can kind of follow along. So the first thing we do is we need to define what we're gonna call our function. So if we access this F4 tab, this other tab, and choose define, or you can just type the word define. Notice it has that space after it, and I'll color code each individual step. Okay, so once you choose define, you're then going to type the name of whatever function you want to call it. Okay, so I'm going to call this function slope. The name of your function should be descriptive, okay, and it should be something that you understand or you remember what it is. So if I type in alpha lock here and type in slope, and deselect the alpha key. So that's the second part. So you use define command, then you name it. The next part after this is you are identifying the order of your inputs. Okay, so the next thing that happens on this is in parentheses after the name with no space or anything, you're going to indicate on your calculator how you're inputting the information. So notice up here I have 1, 2, 3, 4 inputs that I need in order to calculate the slope. And this is where you have to understand or you have to remember how you're ordering these inputs. So for me, I'm just going to list my points. I'm going to list them as a list: h1, k1, h2, k2. Everybody see how I don't put, these aren't written as ordered pair. It's just going to be a list of coordinates, the x coordinate and the y coordinate, followed by the next x coordinate and the next y coordinate. So when I enter this in, okay, I get h1, k1, so that's the coordinates of one point, the first point, followed by h2, k2, that's the coordinates of the next point. Oops. And I close the parentheses. All right, so this is my order of inputs. Okay, so I defined it, I named it, I ordered my inputs. The final step in this is to then give the calculation. So after this, you're going to put an equals, and then you now put in the calculation that you want to happen. Well, the calculation that we want to happen is this calculation up here. So I'm going to take the difference of my k's, and I'm going to divide by the difference of my h's in the same order that the k's appeared. Okay, when you choose your order of inputs, you don't need to order the inputs on how the calculation occurs. You just order the inputs on how you can remember that you're going to enter them. So here I get equals my calculation of the difference of my y's, which is k1 minus k2. You could have also written k2 minus k1, right? I mean, depending on whatever consistent order you put these in. And you're going to divide that by the difference of your corresponding x's, which is h1 minus h2. All right, once you finish this, once you complete all of these steps, you define it, you name it, you order your inputs, you set your function. And once you do that and hit enter, it should say done. This is now stored in your calculator. And the place that it's stored at is located right here, this var link button. Okay, which is that right above the subtraction key. Okay, the second subtraction is how you can access this. So if I want to calculate the slope for this problem, on this problem, from the point -4, -2, and -3, -6, what I'm going to do is I'm going to access var link. So I'm going to go second subtract. Notice it takes me to this menu. And from here, I can scroll down until I get to the name that I identified. Well, the name that I chose was slope. So if you hit a button, you can jump around by hitting the key that corresponds to that letter. So if I hit the key that corresponds to S, it jumps to the first function that you've named with the letter S. Okay, so then you can scroll up and down if you need to go any further. So here's my function slope, so I'm going to hit enter. Notice it pulls this up for me. Okay, so I'm going to enter slope, and then I just list my inputs. And this is where it matters how you ordered your inputs. So you want to enter your inputs in the same order that you chose here in purple. So I chose to enter these just as a list of coordinates. So -4 followed by -2. There's my first point's coordinates. Followed by -3, followed by -6. There's my second point's coordinates. I close this off, and when I hit enter, it's going to give me my answer. The slope for this is -4. Now, here's the nice thing with this, is that now anytime, or if you're using this, anytime you need to take or calculate the slope of 2 points, you can use this function. Okay, even if you embed it in another function, or you embed it in a solve feature, you can calculate the slope of any 2 points using this. Okay. All right. So let's take a look at what we would do if we wanted to create, and we're going to create another user-defined function here for an equation where we're given both the point and the slope, right? All right, so this one now we're going to actually create the whole equation for this. Okay? So if we are putting this into the form where we want to define a function. Okay, again, I'll write all my steps here. I'll color code each one again. All right, so I start with define. So I'm going to, or first of all, are there any questions before we move on? Anybody not get the -4 and want me to come take a look at what they have? Okay, if you I would suggest if you're doing these and you get the wrong answer, don't start deleting your lines of code. Okay, keep it so that if you do have a question for me, you can just scroll up and enter it, and then we can make just the simple change. So like if you accidentally left out a comma, or you mistyped something, you can go back up, highlight it, and change it without having to retype everything. Because sometimes for these as you get a little bit further in, or some of these other ones. It's really or it's not overly time consuming, but it's time consuming to type in all of your entries. All right, so let's look at this, this next one here. So now we're given a point and a slope. Okay, and we call it point slope form is what we could write if we didn't want to do any of the work. But here we're going to put this into slope intercept form, which means we want to define it and give it a name. Okay, I'm going to name it the same thing that I would call it, point slope. Okay, so when I name this, oops, I'm going to go into my other F4, choose define. I'm going to alpha lock and call it point slope. I'm going to abbreviate the word point and then just type the word slope. Again, as long as you choose words that aren't already assigned variables in the calculator, you're good. But you want it to be descriptive enough that you understand what they refer to. All right, so when I decide my order of inputs then, it would make sense that because I called this point slope, I'm going to order my inputs in that order as well. You can choose whatever you want, but I'm going to choose to enter h1, k1, my point, followed by my slope, m. Okay, so there's my order of inputs when I define, or when I select this. So here we get h1, k1, coordinates of my point, followed by m, my slope, and that's it. Okay, and so my final step here is to write my equation. Okay, and so the calculation that needs to happen here, and this is where, again, like you do some planning or you think about what you want. Okay, so what I'm going to do is I'm going to use the point slope form. You guys remember the point slope form of our equation is y minus y1 equals m times x minus x1, right? That is point slope form. So if I enter this and then solve for y, then I'm going to get my equation written in slope intercept form. So that's how I'm going to choose this. Notice you can embed other commands and functions in here. So I'm going to embed the solve feature, and I'm going to put y minus my y value, which is k1, equals my slope, m. Now, remember, your calculator doesn't understand implied multiplication, so you have to explicitly multiply after this variable m, and that is x minus my x1 value, which is h1, and then close that off. And I'm going to solve that for y, so let me move this over so you can see what I'm going to type, and then close it off. So this command right here, this is how you would enter your command here onto your equation. So I'm going to put equals, use the solve feature, and then write my point slope form. So my y minus y1, which again our y1 point is k1, set that equal to m, our slope, times, you have to explicitly enter the multiplication, x minus my x1 value, which is h in terms of my inputs. So here is my point slope form. I want it to solve for y. That way it puts the whole equation into slope intercept form. And then when you hit enter, this gives you your function. And so now if I want to find the equation of the line that passes through -6, -2 with the slope of 9, I can go into my var link, so second subtract. I'm going to look up point slope. So again, if I hit the button, the key that corresponds to the letter P, it pulls up the first function I've defined using that letter. I can scroll up or down from there if I need to. So there's point slope. And then I order my inputs. And again, the way I remembered how to order my inputs was I used the name. So I go point first. So the point is -6, comma, -2, comma, and then my slope, which is 9. Close that off. And when I do this, my output should be my equation written in slope intercept form. And I get the equation y equals 9x plus 52. And that would be my answer. All right, so see if you can use this function, this user-defined function here, to answer the next two questions. So now the next two questions, you're going to use the properties of parallel and perpendicular lines given the equation that's provided, and then find what would be the equation of a line for those. And on this one, even though, again, if you were doing this by hand, the easiest way to do this would be to actually enter your answer in point-slope form. Okay, but for this, I want you to enter in slope-intercept form using the point-slope function that you just created on your calculator. So see if you can answer those next two questions here. If I'm going to solve this problem, I can see in my original here, the given slope is what? 4/3, which means the slope of the parallel line will be same thing, and the slope of the perpendicular will be. All right, so if I use the given point and slope for each of these, I can go in and calculate. Now, rather than find the whole function again, I'm just going to delete the entries and replace them. So with 0.56 followed by slope 4/3, hit enter. So there's my first. Notice that it doesn't have the y entered, so y equals 4/3 x minus 2/3. There's my first equation. And my second one, all I need to do is replace this slope at the end, right? It's the same given point, but of a negative 3/4. And when I evaluate that, I get, notice it switched the order on me, that's fine. Y equals negative 3/4 x plus 39/4. And those would be your answers. Okay. All right. So let's stick with this, and let's go to the sort of last iteration of writing the equations. Okay, and that is, what if you're writing an equation of a line and you are given 2 full points?
So when you're creating the user-defined function for writing the equation of a line through 2 points, you first need to consider the points as being h1, k1 as the coordinates for the first point. Again, the ti89 already has y's and x's stored for other functions, so we need to use different letters. And h2, k2 would represent the second ordered pair. Okay, so when you are looking to define a function, the first thing that we would need to do is to choose the define command. And the define command here, when you look at the ti89, is under this F4 other tab. Choose define. Next, we're going to give it a name. So you want the name to be descriptive. So this is going to be called 2 points. We're going to create an equation given 2 points. So if we alpha lock our ti89 and we spell out the phrase word 2 points, again, make sure it's something that you understand what your function is representing. Next, we need to order the inputs. So here's the 2 ordered pair that we're going to use when we order these inputs. So I'm going to say h1, k1, there's my first point, h2, k2, there's my second point. And so when I enter these in parentheses, oops, we need to deselect the alpha key, and we'll order the inputs. Again, this is just something that you will need to remember the order for these. So h1, k1, followed by h2, k2. All right, so the next part of this is to create the equation. So in order to find what this equation is going to be, we need to, or we'll use an equals, and then we'll type the equation in. So let's take a look at if we were writing this in slope-intercept form, the way that we can solve this, and if we use point-slope form and then the solve feature to put it in slope-intercept form, what we can do is we can use the equation here to solve for y minus y1. Again, the y1 value is k1 equals the slope. So here when we calculate the slope, we're going to take the difference of our y's, k2 minus k1, over the difference of the corresponding x's, which is h2 minus h1. And we're going to multiply that by our x value. And again, we're choosing x minus our x1 is, our x coordinate is h1. And we're going to solve this whole thing for y and close it off. And this is going to give us our equation written in slope-intercept form. So if we use the equal sign and then type in this whole equation, again, we'll use the solve feature. Y minus y1 equals the slope, k2 minus k1 over h2 minus h1. Oops, there's the slope, times x minus x1. Again, the x1 is represented as h1, comma y tells us we're going to take that function and we're going to solve for y. So you can embed this solve feature inside this user-defined function. And so if we type what we have, y minus our k1 is equal to our slope, which is the difference of y, so k2 minus k1, over the difference of the corresponding x's, which is h2 minus h1. And then this is all times the quantity x minus our given x coordinate, which we established was h1. And so if we solve that function for y, close it off, we now have our equation. So hit enter, we see the word done. That means that this is now stored in our user-defined functions, which we can access here in this second subtraction var link command. And if we want to find it, we called it 2 points. So if we just click the key with the letter that corresponds to the first letter of that function, the t, the 2 points, and we access that, we can then type in the coordinates of our points. So 1, -10, followed by 11, followed by -9. So again, we're entering this as just a list of 4 points, 2-ordered pair, all separated by the commas. And when we calculate this, we get our answer of 1/10 x minus 101 over 10, and there is our function.
All right, so for both of these examples here, when we are writing in slope-intercept form, we're simply solving for y. So if you take your equation, 8x plus 3y equals 6, comma y, that tells the calculator what you want it to solve for. And again, I do want it to expand, so if I go to the front, I can choose the expand command and then jump all the way, second right arrow, all the way to the end. Close that off. This will give me my rational form. So 8/3 x is my first term, or a -8/3 x, and then my +2, and that would be my answer. Okay. For the second one, same process. Use the solve feature. Type your equation. This one is already written in point slope form. Now, your calculator understands implied multiplication after a number. So -6 with the parentheses here, it is fine. You can leave it like that. Comma y tells it what you're solving for, and I get my equation here. I need the y equals on this one, but -6x minus 46 for my equation. All right, so I'm going to stop right here. This gives you a little over 10 minutes. Okay, I'm going to open up this assignment. This assignment has both Chapter 3 and Chapter 4, so we haven't gone through all of this, but you can probably do the first third of the questions. Okay, we'll finish these up. We'll finish these, or not, 3. We'll do these on Friday and finish it up. But it is, I mean, it is designed where these are self-paced, right? You should be able to look through the notes and be able to go through them if you want to finish this, or if you feel like you're not going to be able to work fast enough to finish it on Friday. You can do some of them ahead of time here. All right, so where we ended was talking about the average rate of change. Okay? And if you recall from the chapter 3 notes, average rate of change is just slope, right? So we can actually use the slope function that we defined last time to solve these if you don't want to calculate it out every time individually. And so this first problem, once again, what you have to remember to do is you have to actually solve for the corresponding x or the corresponding y value at each of these x values. So the beginning of the interval to the end of the interval, and then you just take the slope of those 2 points. So if we take this 0.5 and we evaluate, we take the 0.5, evaluate what f of 5 is going to be. And doing that with the ti89, remember you can do a couple different things. You can just type it directly in. You can use the with key. You can type the function in the y editor and then evaluate it as using function notation. What I'm going to do here is just type the expression. Since I am going to do this twice, it's worth it to me. I'm going to use the with key. To me, that's a little more efficient than retyping everything multiple times. So I'm going to take the square root, or negative square root of x plus 3, close that off, minus 5, and then I'm going to use this with key, and I'm going to substitute in x equals 5 for the first set. And now, I do kind of anticipate right here that I'm getting the square root, and I want to write my answer as in decimal, so I'm going to enter a decimal in my entry. Because I'm in auto mode, if I put a decimal in my entry, it'll display as decimals. I could also have picked or selected this green diamond button, and that if this little diamond shows up and you're in auto mode, it'll give you the answer as a decimal as well. So here is my number. Okay, and so when I evaluate this, I get negative 7.8. Now, I'm just going to write negative 7.8, but when I go in and I calculate this, I'm going to highlight the exact number. Okay, always use exact answers when you're doing your calculations. Okay, and then the second point that I need to find is the point when x is 10. And so all I need to do on my calculator right here is replace the 5 with a 10. So I don't have to rewrite everything again. And I get negative 8.6, or negative 8.6 again approximately. Okay, I'm just entering those here, and so when I find my average rate of change, I'm now going to go into my var link menu. I'm going to hit the button that corresponds to the letter S, so 3, that takes me to the first function I've named with a capital, or with an S. Mine happens to be slope, and now when I enter this in, I need to find the slope of the points, and the points are what I have written right here. So the 2 points that I'm finding the slope between is this first point 5 and the negative 7.8. So I'm going to go up and highlight the exact answer, hit enter, and it'll pull that answer down for me. Oops. Go up and enter that calculation, and then comma, the next point is the x coordinate 10, comma, the corresponding y value at 10, which is this negative 8.6. Going to hit enter, highlight that, hit enter. And when I close off the parentheses and calculate, I get my answer, which is negative 0.155 when I round it to, or actually to 4 decimals. So it's negative 0.1554. All right, So I want you to see if you can answer the question for this next problem here. Again, just using the slope function that you've already defined on your calculator. Good morning. Right, so for this problem, again, it is just a matter of identifying what are the points that you're looking at. So if we are evaluating the f function, which is this middle column, when x is 0 and when x is 4. So here's the corresponding y values. So we have 0 and 9 as 1 point, and we have 4 corresponds to 2 for the other point. And so it's just a matter of calculating slope. Our link menu, hit the button with the letter S, access the slope function, and then we type in these points. So remember, we're just entering them as a list of points. So 0, 9, the second point, 4, 2. And when we close that off and get our answer, we get -7/4 for the average rate of change, which is a slope again. Okay. The last problem, we're in the g functions now. From the g, we're still doing our 0 and 4. And so the point is 0, 6, and the second point is 4, 0. And if we calculate the slope between those, I'm just going to go in and change 0, 6, 4, 0. Oops, close that off. And I get my second answer to be -3/2. All right, so using the slope feature after you define it can be done that way. All right, the next, go ahead and try this really quickly. Again, we've already talked about it. This is just doing the function notation with a quadratic function, but it's the same as what we talked about earlier. So see if you can answer this. All right, how many use the with key? And that's what I would do. Did anybody write it in the y editor and then evaluate it function notation? That's another possibility. Again, that would be one that I would do if I needed to either evaluate multiple, more than just one, or especially obviously if I needed to graph it, I would do it in the y editor. The last option is, how many of you just entered -4 instead of x every time, like when you wrote out the expression? Okay, that's the other way that students tend to do it. Just be really careful. If that's what you choose to do, make sure you put the -4 in the part that's being squared in parentheses, because if you just type -4 squared without putting parentheses around the -4, it'll give you the wrong answer. It'll have the wrong sign to it. So again, to me, because this one has multiple x terms, I would probably use the with key. So if I type my expression, the with key, vertical bar, and then I want to evaluate it when x is equal to -4, hit enter, I get my answer to be -13 for that. Oops. All right. All right, so the next type of problem are composition of functions. Okay, this is where you have a function embedded inside of another function. And so the easiest way to do this is to type each of these functions into the y editor. Okay, and then use the function notation at the home screen to evaluate. So if I'm going to do that, I'll go into my y editor, so diamond F1. Okay, and I'm going to type my f function into y1. So I have -8x + 2, hit enter. And I'm going to type my y function, or my g function into y2, which is 6x - 1, and hit enter. So just understand, or again, remember here that your f is the y1, your g is the y2. So that when you go back to your home screen here, if you want to evaluate f of g of x, the outer function is y1, of y2 of x. We aren't evaluating it for a specific number. We're leaving our answer as an expression. And so this keystroke entry right here is going to evaluate the f function where every x in the f function is going to be replaced by the entire function g, which we call y2. So when you enter this, it gives you the expression that is your answer. Notice it's written, it's not written in that sort of standard form. You can write it, or you can write it either way, but I'm going to put the x's first because that just tends to be how it's written. And so if you want to evaluate the second function, the g function, now you're going to take y2 of y1 of x, close that off, and this is going to evaluate the composition with the other outer function. So now the g is the outer function, and the f is the inner function. All right, so see if you can kind of follow that same process here for the combination of functions. Again, the combination of functions is adding, subtracting, multiplying, and dividing. The composition of functions is where you're embedding an entire function into every variable in another equation. But see if you can do all four of these versions of the question. So once again, you're working with these multiple functions. So if we enter these into our Y editor, these are different functions. So I'm going to go clear what I have. Okay, and I'm going to re-enter my f function. Again, I'm going to put in y1. Whatever you do, just make sure you're organized with it, that you remember which one you put in where. So negative 10x plus 4. And for my g function, 11x minus 4. And so when I go back to my home screen, I can simply type in what I'm expressing here. Remember, f plus g of x is just taking f of x plus g of x, which means y1 of x plus y2 of x, with the way that we've typed these or entered them. So y1 of x, we're not evaluating it for anything, so we just leave the x, y2 of x, and you get your answer, which is x. F minus g, so again here I've already got my y1, y2, so I'm just going to change the sign between these. So f of x minus g of x. And when I do that, I get, I'm going to reorder my terms, so negative 21x plus 8. Now I'm going to take f times g. Once again here, I'm just going to go in and multiply this. Notice it gives me the factored form. I don't want the factored form. I want to express as a polynomial. So if I use the arrow key to go in front, what command can I use to write it as a polynomial? Expand. So F2 algebra tab, choose expand. Notice I can jump to the very end again by hitting second and then that right cursor or right arrow. And that gets me to the end, close off the expand, and this now allows me to write it in the polynomial form. Okay, now this last one, really, because these are, the powers are the same for f and g, it's not going to expand it out into anything where you need to use the long division. So you don't really need the expand command. It's not going to do anything for you. And in fact, if you just were to, I'm going to highlight that function so I can modify it and just turn it into division between the two functions. It's just going to write your expressions as they were. Nothing canceled right there. And so you can either write what the calculator shows, or if you recognized that nothing canceled here, you could just, like this one, you can just enter as it is. If the numerator was a higher degree than the denominator, then you'd probably want to put, or you could put the expand command. But really all you're looking for on a problem like that when you're writing the quotient of functions is, do they have any common factors that cancel? So you don't necessarily need to do long division on a problem like the combinations. All right. The last part from chapter 3 is trying to determine whether functions are even, odd, or neither. And the way to do this has to do with actually the comparison that you need to make. Okay? And if you don't recall, here's the comparison for the rules for those. Okay? And that is, if two functions are even, or if a function is an even function, that means that the original function itself is equivalent to the function when you evaluate it with the opposite of x. Okay? And so if it's an odd function, then the original function itself is equivalent to the function notation when you expand it as when you replace every x with a negative x. And then anything other than those two rules, it is neither. Okay, so if you take a look at this, basically what we're going to look to do on our calculator is to create three functions. We want to type in our f of x, or we can just compare that. We also need f of minus x, and then we also need negative f of x. So these are the three forms that we're going to compare. And so if we take our calculator and we write the function in, oops. So go to the y editor, and what I'm going to do right here, because I see in this problem I have three functions, is I'm just going to write each of these in a separate y input. So 3x cubed plus x, I'm going to add to y1, the square root of x, add to y2, and 3 minus x squared, add that to y3. And so now when I go into my home screen, the test that I'm going to use for each one is all three of these. Okay, I have my original function right here. So if I take y1 and evaluate negative x, and then see what that gets, is this any different from this? Yeah, they're different, right? So it's not even. So I go to my next test, which is, evaluate go -1 times y1 of x. So this is the last one, right? We're just changing the sign of these. Okay. It looks like from the form that I wrote it, I'll put expand around these so it gives me the full expression. Okay. And what I see is, does this expression here, does minus f of x equal f of minus x? Are these two the same? Yeah. The fact that those are the same means that this is an odd function. Okay, and we do the same thing with each of the other two. So if I take my test right here, again, I'm just going to highlight this and change the y1 to y2. I'm going to test now for this second function. Is square root of -1 or negative x equal to the square root of x? No. I'm going to highlight this, change it to a y2. When I evaluate this, is negative root x equivalent to the square root of negative x? No. So this one would be neither. And then do the same thing here with the last ones. Change it to y3. My h function, so when I evaluate this, is 3 minus x squared equivalent to 3 minus x squared? Yes, and so I know I have an even function. And so that is testing for even, odd, neither. All right, so that's the rest of chapter 3. I am just going to quickly go through the chapter 4 again, but this is the section that you actually did with your calculators. Okay? And so this should all be review, but I'm just going to kind of quickly go through it. solving the system, we need to find our system solving template, which is located in the custom tabs. So if you hit second home and access these custom tabs, F3 is your system solving template. And so if you choose that, what you can do is enter your equations directly in before the ands. So x plus 7y equals negative 51. Scroll over and you get, or type in x minus 3y equals 29. Once you do that, the template's already set up to give you your answer. So 5, negative 8 would be your two coordinates. If you have 3 variables, remember the idea is the same. You go into the custom tabs. You still access your system solving template, which is F3 option 4. But this time you actually need to include space for a third equation, and the easiest way to do that is just alpha lock what you have and type in, I'm going to put another space, then type the word AND space. Again, the space key is this white underscore at the change of sign button. And because I'm adding another variable, I need to change this. I'm going to deselect the alpha key and comma, I'm going to add Z, or actually which one? Z as my third variable. Okay, and now I'm going to fill in the equations in each of these open spots. So I have x plus y plus z equals negative 7. Here, after my first and, write the second equation, 8x plus y minus 2z equals negative 85. And then finally, after the last and, write my final equation, x plus 4y plus 6z equals 9. And since I've already changed my variables to add that z as well, here's my solution, negative 9, negative 3, and positive 5. The answer is written as an ordered triple. Next year, you guys will do a little bit more with this. You'll also be expected to do this by hand next year. Okay? Again, I'm not taking the time to do that. If I gave you a problem like this, it would be something you could use your calculator for. Right, so that's systems of equations that we went through, and then matrices, again, next year you'll have to do this by hand as well, but I want to show you how to use your calculator for it. We've already talked through this process, but remember you can enter matrices or directly in your calculator by using the brackets. So if we enter our first matrix here, just list the contents of each row separated by a comma. So top row is negative 3, 6, negative 5. When you want to jump to the next row, it's a semicolon, which is second 9. And then type in the second row, so negative 8, comma, negative 3, comma, 9. And then you can close this off. Now, if you're doing multiple calculations with the same thing, you can store this into a variable. So using this STO button right here. So if you hit store and then let's call this A, since that's what it's asked here. Now the calculator doesn't determine between capital and lowercase, so we can just leave it lowercase a. You can do that. Now you don't specifically have to though, because this problem right here, you're taking A plus 5 times B. Since you're only doing one calculation with this matrix, you're going to enter it anyway. You might as well, or you could also just enter your calculation. So plus 5 times, and then we could put our next matrix, the B, which is 0, comma 3, comma 2. Semicolon jumps to the next line, 4, comma 4, comma 5. Close off the brackets. And then I close off, I didn't have parentheses. So this is my, this is the entire quantity here written out. And when I hit enter, I get my calculated value, negative 3, 21, 5. Along the top row, 12, 17, 34. In the bottom row. So this was possible. There's no dimension error on this problem. Now, what about the second problem? Before you even start typing it, you should test it and see. So here we had a 2 rows by 3 columns, 2 rows by 3 columns. Here we have 2 rows by 3 columns, and we have 3 rows by 2 columns. Are you going to be able to add those together? No. Now, could you multiply these together? If you remember the rule for multiplying, if the middle dimensions are the same, then that result, the product, will have the outer dimensions. So you could multiply A and B here, but you can't add them. So actually, when you are looking at this, this one is a multiply. So yes, this is possible. Okay, so let's go ahead and calculate this value. Once again, since we only have one value that we're calculating, it's not bad just to type in the matrices. So bracket 8, 7, 2, semicolon to jump to the second row. -1 to 4. Oops. Close that bracket off. So here's our first matrix, and we are multiplying this. Oops. Multiplying this by the second matrix. Now we could have also stored these as A and B and then multiplied. So 8, 1 here, jump to the second row, -7, 7. Jump to the third row, 8, 9. Close off our bracket. So that ends the second matrix, B. And when we hit enter, we get our solution, which is 31, 75, 10, and 49. All right. The last couple things that you were being asked to do in Chapter 4 had to do with using the determinant. And so remember, when you are setting up a determinant to see whether whether a set of 3 points can be contained in the same straight line, you'll set it up using this matrix, where you put the x and y coordinates, and then the last column is going to be 1. And if you take the determinant of that and it's 0, then the lines are collinear, and if it's not, then the lines are not collinear. Okay, so see if you can calculate or determine, following that example, whether these points are collinear or not. And again, the determinant, you can just type in DET if you want, or it's in the math catalog I'll show you here in a second. Especially because the letters are so close together, I would alpha lock this and type in DET. They're all right here. So there's determinant, close that off, or I open the parentheses, and then inside you're going to put the matrix that you've created. And again, the matrix is going to be -8, 8, 1. -6, 6, 1, 4, -4, 1. So this is the matrix you'll use to test this first set of points. So if I enter this semicolon to jump to the next row, again semicolon to jump to the final row, close off the brackets of my matrix, close off the parentheses of my determinant, and I get my answer 0. Since the determinant of this is equal to 0, that means that yes, these are collinear points. Okay. For the second example, the matrix that I would use is 6, -2, 1, 2, -1, 1. Again, just writing your x, your y coordinates, and then 1. So let's test the determinant of this. Now, the other place, instead of just typing the determinant, you could also find it in the math catalog, which is second 5, and then under matrix, which is option 4 here. Determinant is the second option. and you do the same thing, right? Enter your the bracket form of your matrix. So 6, -2, 1, semicolon, second row, 2, -1, 1, and then the final row, -5, -4, 1. Close the bracket, close the parentheses of the determinant, and when we do, we get our answer to be 19. Okay, and so here, when we are looking at this, we see that no, this is not a set of collinear points. Right, the final type of problem that you see in Chapter 4 is finding the area. The area is calculated by taking 1/2 of the determinant that's created using the same kind of process that we just did. And if we take half of that and take the absolute value of it, we're looking at a magnitude of positive value to find area. So if you basically take this whole calculation 1/2 times the absolute value of the determinant, you'll get your solution. And so same process. Set up your matrix, -7, 2, 1, -3, 8, 1, -5, 6, 1. And if we set up the determinant of this and multiply that by 1/2, so take the absolute value of this and multiply by 1/2, we're going to get our total area. And so if I just calculate that from the beginning, so 1/2 times, I can go into find absolute value. I can either type ABS, or I can go into the math catalog under number, and it's this second option here. And then I put my matrix, or sorry, the determinant, which again I can either type in or go back into my math tab, and under option 4, select determinant. And so here when I type my matrix, I get -7, 2, 1, semicolon, jump to the next row, -3, 8, 1, semicolon, the final row, -5, 6, 1. Close the brackets, close the parentheses, close the 1/2 times. And I don't know if I put parentheses around that or not. I did. So, or the absolute value sign, I close that. Okay, and so I should have everything here that I need. I get my answer to be 2. And so the area of this triangle would be 2.